Hi everybody, welcome to lesson 1.5 and 1.6 where we're going to add, subtract, multiply, and divide rational numbers. So we're going to see integers today and we're also going to see fractions because those are rational numbers too. So let's get started. You're going to want to have your 1.5 notes out. If you need to pause the video to catch up with me, go ahead. So first we're going to look at addition and subtraction. When it comes to integers, when you have both positive numbers and you're adding them together, of course you're going to get a positive result. We've known that since we were adding numbers. But then we learned that if we take two negative numbers and add them together, for instance, if we have seven negatives and we add 3 negatives, we're going to get a negative result. So anytime we take negatives and we add more negatives, we get a negative answer. Then we learned about opposites, where we have a 5 and a negative 5, those are opposites. And if you add opposites together, they make 0 every single time. And so this would be a diagram of that. If you have 5 negatives and you add 5 positives, they just cancel each other out, they become 0 pairs. Once we get different signs, then things get a little bit more complicated. If you want to go ahead and pause the video and see if you can answer these problems, see how much you remember from 7th grade, you can. But when we're taking 4 and adding -3, or any one of these examples here, we end up getting a positive answer for all of them, even though the signs are different. Why are these answers all positive? Well, I bet you're thinking that when you look at this, there are more positives than there are negatives. Same thing here, there are more positives than there are negatives. And here, same thing. Now let's try these ones. Over here, we have again a negative and a positive number. The signs are different and we're adding them together. But in this case, when you add, you get all negative answers. Why are they all negative? How can you just look at this problem right here and know the answer is going to be negative? Well, same thing as this. There are more negatives. Here there are more negatives, where we end up getting a negative answer. So last year, you may have learned this with the positive and negative chips, or maybe you did this on the number line last year. Whatever your brain thinks of. I mean, I like the number line where if I'm doing -9 plus 1, I'm over here at -9 and I jump 1. Here if I'm doing 5 plus -10, I'm at 5 and I go backward 10 places. But the number line is very useful with this. Now, without a calculator, are you able to evaluate this part in your notes? 5 minus -6, what would that be? Without a calculator, 2 minus -13. What does that double negative mean? Minus a negative. What is that the same as? Pause the video and give them a try. Remember, it's the same as adding. So when you do 5 minus -6, it's 11. And actually, if you type it into the calculator, 5 minus -6, it's going to tell you 11. Whenever you see two negatives together, it's like a not. It's yes, it's a positive. So 2 minus -13 is really the same thing as plus. So hopefully we remember that from last year too. All right, now we're going to try some examples in our notes. These examples that we're going to work with are going to be integer examples. So for instance, 9 minus 13. I like to think of temperature. If we have 9 degrees and it drops 13 degrees, how cold is it going to be? Well, that would be -4. Let's try this one. 6 minus -3. Remember that this is the same thing as plus. So in your notes, you may change that into a plus sign. We wouldn't need a calculator for this. We change to plus and we get 9. Here we have -21 minus -7. So again, I have minus a negative, which means it's really going to be the same thing as adding. So think if it's -21 degrees and it increases 7 degrees, we would be at -14. Okay. Think temperature. That way you can kind of think moving along the number line. Okay, try this one here. Think temperature. If it's -3 degrees, and then it drops 4 degrees, and then it drops 11 degrees again, how cold is it going to be? Remember last year how you added the 11 plus the 4 plus the 3? So this would be -17. Let's try another one. Right here. So copy it down, and then do you see anywhere where you need to simplify? Maybe right here. So if I change this to a plus, I really have negative 19 plus 6 minus 8. So think if it's negative 19 degrees, and then it goes up 6 degrees, we would be at negative 13. And then if we went back 8, we minus 8, I think we'd be at negative 21. If I'm doing this right in my head. So there we go, kind of thinking number line back and forth. Okay, now we're going to look at some other rational numbers where we're going to see some fractions. So here we have 1/3 and we're adding negative 2. Give you a second to write it down. Well, on here, it might be kind of hard to use the number line. Maybe some of you can use the number line. You can think like that in your head even when there's a fraction. But I'm going to write this out as a fraction, 1/3. And if I add negative 2, I can write that as a fraction over 1. Now, if you remember with fractions, we need to find a common denominator. Common denominator here would be 3. So if I multiply top and bottom by 3, this would be 1/3 plus, this would now become negative 6/3. Well, think, negative 2 is the same as negative 6/3. Now I can add them together. So my denominator would be 3. 1 plus negative 6 would be negative 5, and I had negative 5/3. You could also write that as negative 1 2/3 if you chose a mixed number. But right here in 8th grade, we generally leave everything as improper. Okay, so there's our first one. Now there's other ways of doing that. That's just one way. I want to kind of refresh your memory with fractions. Here's 7. So we have negative 1/6 minus 2/3. Again, fractions, we're subtracting. We have to have a common denominator. I particularly like this if it was more horizontal. So I'm going to rewrite that. Now, when it comes to a common denominator between a 6 and a 3, the least common multiple would be 6. So I'm going to change this to a 6 by multiplying by 2. So now I have negative 1/6 minus, this is now going to be 4/6. Now I have a common denominator. So my denominator is going to be 6. How many? Negative 1 minus 4. Temperature's negative 1, it drops 4, I'd have negative 5. And that's how I would do this one. So common denominators on adding and on subtracting, and then leave your answer as a proper or an improper fraction. Okay, here's 8. 7/16 minus a negative 1/2. So right here, when you see minus a negative, that can be simplified. We can change that into a plus. So really I could rewrite this problem as 7/16 plus 1/2 to simplify it. Now again, to be able to add fractions, I need a common denominator. 16 would be the least common multiple, so if I change this to 16, I can multiply by 8. 7/16 plus, now this, if I rewrite this fraction, the equivalent fraction would be 8/16. Makes sense, 1/2 and 8/16 are the same thing. Now I can add them together. So I have 7/16, I'm adding 8/16, I would then have 15/16. So just a recap of adding and subtracting some fractions. Okay, here's 9. This one's kind of tricky. I actually used to assign this as a homework problem, but then I had a lot of kids that had made mistakes on it. So we're going to do this one together in our notes. So imagine as you're writing this that I have like a cup of milk, and I pour out a 1/2 cup, and then I pour out a 1/3 of a cup, and then I pour out a 1/4 of a cup. Well, think to yourself, would you have any milk left in the cup? Or would this answer be negative? Let's try it. Because I'm subtracting, I need to have common denominators. I'm going to start off by writing the number 1 as a fraction, 1/1. Now I need a least common multiple of all of these numbers. Well, that would be 12. So let's change them all to 12ths. To do that, I'd have to multiply the first one by 12. I'd have to multiply this one by 6, top and bottom. I'd have to multiply this by 4, same thing with the top, and I'd have to multiply this by 3, same thing with the top. So I'd end up with 12 twelfths minus, here I'd have 6 twelfths, that's the same thing as half. Here I'd have 4 twelfths, and here I'd have 3 twelfths. So I just renamed each of these fractions here. I renamed them to their equivalent fraction by finding common denominators. Now, how many twelfths are we going to have? The denominator stays the same. 12 minus 6 is 6. minus 4 more is 2. Now minus 3 would be negative 1. So I wouldn't end up with any milk in the cup. I have a negative answer. So as long as you change that first number to a fraction, find common denominators, it becomes a much easier problem. All right, and 10. Here's 10 right here. So we've got negative 5/6, and we're going to add negative 2/3. I'm going to rewrite this so that my fractions aren't a side slash. Okay, common denominator again. I feel like we're doing a lot of the 6 and 3. So 6. So I'd multiply top and bottom by 2 to make this also 6ths. And here I'd have negative 4, 6. Now, denominator stays the same. If I have negative 5 and I add negative 4, 5 negatives plus 4 negatives would make 9 negatives. Now, I couldn't leave my answer like this. I can't leave it as negative 9/6 because it can be simplified. Both of these numbers are divisible by 3. I would get negative 3 halves or negative 1 1/2. But really, we can leave our answer improper. Let's practice doing that rather than changing everything to mixed numbers. Okay? So that was your adding and subtracting review where we find common denominators. Let's move on to multiplication. So if we do a little investigation, you'll see this in your notes where you've got 2 positive numbers that you multiply and 2 negative numbers that you multiply. And here your signs are going to disagree. They're going to be different. So feel free, pause the video. Give them a try. If you need to use a calculator, you can. Okay, now that you've tried it, let's check the answers. So notice here that for all of these, I'm getting positive answers. Anytime that my signs are the same when I multiply, they're both positive or they're both negative. I can think of my signs agree. They're both the same. And that is positive. To agree is a positive thing. Now over here, my signs are different and I get a negative answer. Negative, negative, every single one. Well, whenever you multiply 2 numbers and if the signs disagree, you get a negative answer. So think of to disagree, that's a negative thing. So when our signs are different, when we're multiplying or even dividing here, we get a negative answer. Okay, quick way to remember it. All right, so let's practice some multiplication with our integers. So with this first problem, I'm going to give you a second just to write it out. Pause the video if I'm going too quickly. But a good method for this is to expand it, to expand it out. So 2 to the 4th power, write it as 2 times 2 times 2 times 2. So if I expand this problem out, I would write this as 2 times 2 times 2 times 2. Then I'm multiplying that by negative 1 to the 3rd power. Expand it out. Another way you could do this is by writing them all in parentheses. I kind of like that almost better. And then I have negative 1, negative 1, negative 1, and then I'm multiplying it by 2. Then when you're multiplying, grab 2 numbers at a time. Multiply these 2, you get 4. Multiply these 2, you get 4. Multiply these 2. And then grab 2 numbers again, okay? And work your way down. Feel free, pause the video, give it a try. Let's check and see your answer when you're done. Did you get negative 32? Yes, cool. Let's try this one. Again, copy it down and then expand it out. Negative 3 times negative 3 times negative 3 times negative 1 times negative 2 times negative 2. Put them all in parentheses like you did here and then gather them up. Multiply 2 at a time, okay? Once you have it written down, I want you to pause the video and then you can check your answer with mine. Just by looking at this, I know if I have 3 negatives here, that's going to make a negative answer. And if I have 2 negatives here, that's going to make a positive. So I think my answer is going to be negative. Oh, no, positive, I mean. Whoops. Okay, so I gathered them all up. I got 108. Did you get 108? Yeah, hopefully. So that's how you do this. That's a bunch of integers. I know you can multiply 2 integers together, so I want to challenge you a little bit. Okay, on number 3. This formula right here changes the temperature reading from Celsius to Fahrenheit. So what is the temperature in Fahrenheit when the Celsius temperature is negative 15 degrees? So let's say that you're going to Canada and it says in Canada that it's going to be negative 15 degrees there. Well, what is that going to feel like to us? Let's convert that to Fahrenheit. So I'm going to begin by writing down this formula. Fahrenheit equals 9/5 times Celsius plus 32. Now it tells us the Celsius temperature is negative 15 degrees. So I'm going to replace it in the formula for Celsius. Instead of writing C, I'm going to make it negative 15. So this is going to be 9/5 times negative 15. There we go. Now I'm going to solve for Fahrenheit. So you notice here I have to multiply fractions. I have 9/5 times negative 15 over 1. Now remember, last year you don't need a common denominator when you multiply, but you always want to simplify before you multiply. So right here I have a numerator and a denominator that both are divisible by 5. So 5 divided by 5, 1, and then negative 15 divided by 5, that would be negative 3. Now I can multiply across. 9 times negative 3 would be negative 27. Okay? Then I can add the 32. So negative 27, and if I add 32, would be positive 5 degrees Fahrenheit. So really, negative 15 degrees Celsius, I mean, it feels really, really cold, but it's not terrible. It's not that bad if we change it to Fahrenheit. So that's how you would do this when you convert. So multiplying fractions. Let's try this one. On number 4, negative 7/10 times negative 5/8. Now just before we even start with this one, I'm taking a negative fraction and multiplying it by another negative fraction. That's going to give us a positive answer. The signs agree, they're the same. A negative times a negative is a positive. Now, looking at this, can I simplify? See the 10 and the 5, this numerator, this denominator, they're both divisible by 5. So if I divide by 5, I get 1. If I divide this by 5, I get 2. So now I can multiply straight across. 7 times 1 in the numerator is 7, and 2 times 8 in the denominator is 16. A negative times a negative makes a positive. So I just have 7/16. Remember, no common denominators when you're multiplying. Okay, let's try this one. We're going to see some order of operations. We got exponent here and then addition. So give it a chance, copy it down. Now whenever I'm showing this to kids, I always say, when in doubt, write it out. So I don't want you to do this exponent in your head. Write it out. So if I have 2/5 to the second power, I really have 2/5 times 2/5. And if you write that out, that's 4/25. So right here, just by doing the exponent part, I have 4/25. Now I can bring down the rest, plus 1/5. Okay, so when in doubt, write it out. I want you writing those out. You'll make less mistakes. Okay, so now at this point, to add these fractions together, I need to have a common denominator, and it would be 25. So let's make this into 25ths. So 4/25 plus this would be 5/25. How many 25ths would we have then? 4 and 5 make 9/25. So I took this right here, this expression, I simplified it to 9/25. Let's try another one like that. Here on 6, here we have 3, and I'm multiplying it by 1/3 to the third power, subtract 1. Okay, so we got different operations. We got multiply, exponent, and subtract. So follow your order of operations, exponent first. So if I'm doing the exponent first, write it out. 1/3 times 1/3 times 1/3. Do you see how that'd be 1/27? So this changes to 1/27, multiply by 3, subtract 1. Okay, now I'm ready for the next step. My next step here would be to multiply before I subtract. So I'm going to make this a fraction. Remember, no common denominator. I just simplify before I multiply. So here, the 3 and the 27, divide by 3, I get 1. Divide this by 3, I get 9. So 1 times 1 in the numerator, 1 times 9 in the denominator, now minus 1. Now this looks a little tricky, but it's really not. I need common denominators, and I know that 1 is the same thing as 1/1. So couldn't I just change that to 9/9? Isn't 9/9 the same thing as 1? And now I can subtract. So I'm going to get 9ths. 1 minus 9 would be -8. Woo! There we go. -8/9. So all of this right here, this expression, simplifies right down here to -8/9. So not too difficult, but you do have to remember common denominators with adding and subtracting, and then multiplication and division, you don't need to do that. Okay, so now that was multiply. Let's quickly review division, and then we'll be done. Okay, so when you divide fractions, you get the same answer if you multiply by the reciprocal. So in this case, when I have 1/2 divided by 3/4, whenever I see a division problem, in order to do this without a calculator, I'm going to keep the first fraction the same, switch the divide to multiply, and flip the second fraction. You might have called it before keep, switch, flip, or keep, switch, reciprocal, or keep, switch, change, whatever they called it last year. But in order to do this without a calculator, I keep, I switch the sign, and I flip the second fraction. So right here, this is a couple pictures of my kids. This is Gavin, this is Nolan from a long time ago. So let's say that they're a division problem. See Gavin standing up here, Nolan? If I change them from a division problem to a multiplication problem, what's going to happen? Well, Gavin should stay the same, just like the first fraction stays the same, but the second one is going to flip. So there you go. See, Nolan flipped over. So here, division problem, I'm going to keep, switch, flip. Okay, let's try this. Go ahead and write it down. I'm ready to divide, no calculator. So I keep the first fraction the same, I switch the divide to multiply, and I flip the second number. That's the reciprocal. I'm flipping it. So it still stays negative. I'm just, whoops, don't forget to flip. I'm changing it from 5/2 to 2/5. Keep those parentheses around it if you'd like to. Now think about this. I have a positive multiplied by a negative. The signs disagree. My answer is going to be negative. Okay, let's not forget that. So we're going to simplify before we multiply. 4 and a 2 are divisible by 2. Divide by 2, I get 1. Divide by 2, I get 2. And multiply straight across. 3 times 1 is 3. 2 times 5 is 10. And remember, a positive times a negative is a negative. And there's my answer. So with division, you change it to multiply, flip, and then simplify before you multiply. Let's try another one. This one looks a little bit different. It's saying, what is the value of x divided by y? If it's blurry to you there, this says x divided by y when x is -6 and y is 2/3. Okay, it would be pretty silly if I wrote it like this. Think about x divided by y written like that. That would be me taking -6 divided by 2/3 if I wrote it like that. That looks weird. So I'm going to change this, and I'm going to write it x divided by y like that. Okay? It's going to make it a much easier problem. So I want to take x, which is -6, and divide it by y, which is 2/3. X divided by y. Now, my first fraction stays the same, so it would be -6 over 1. This changes to multiply, and I flip the second fraction, reciprocal. So this would be 3/2. Now, simplify before you multiply. Here, I got a numerator and denominator divisible by 2. Divide by 2, 1. Divide by 2, I get 3. Now multiply straight across. -3 times 3, -9. And that's what I end up with for my answer. Okay? Not hard, but we're going to see it more in an algebraic notation. Okay, on 10, -a over b minus c, or the opposite of a divided by b minus c. So we got some things to plug in here. Here, when I have division with a fraction bar, imagine me writing this -1/2 on the top and -6 on the bottom. It just would look weird. So I'm going to rewrite this as -a divided by b and then subtract c. That's how I'm going to write it down when I copy it. So I have -a, or the opposite of a, divided by b. Well, if a is -1/2 and this says the opposite of a, that would make it +1/2. Because imagine this would be -1/2. That would make it a positive. So I have +1/2, and I'm going to divide it by b, so that's 3/4, and then I'm going to minus c. So I'm minusing c, which is -6, minus -6. Okay, so if I read this again here, I have the opposite of a, which is +1/2, divided by b, and then take away C. Okay, now I look like I have an order of operations problem. Let's go at it here. So I've got 1/2, change this to multiply, flip. Okay, then right here, I could simplify this and make this add. Okay, now I'm ready to do the multiplication. Simplify before I multiply here. Divide by 2, and I get 2/3. Multiply straight across, plus 6. Now don't overthink this. Imagine if you had 2/3 cup of flour and you added 6 more cups of flour. Wouldn't you end up with 6 and 2/3 cup of flour? Yeah. So 6 and 2/3. You don't need to overthink it and find common denominators. You'll just get an improper fraction. So that's what you'd end up with. 11. Ooh, look at this one. 0.25 squared divided by 3/4. Just look at that. I mean, right now I'm looking at this thinking there's no way I want to take 0.25 times 0.25 when I square it. No, thank you. Is there a different way that we could name 0.25 rather than as a decimal? Are you thinking fraction? Me too. So let's rename this as 1/4 to the second power divided by 3/4. That's going to make it an easier problem. Remember, when I do the exponent first, write it out. 1/4 times 1/4 would be 1/16. So right here, this is going to change to a 1/16. Remember, when you get those exponents, write it out. Divided by 3/4. All right, now go ahead. Keep, switch, flip. So I keep the first one 1/16. I switch this to multiply, and then I'm going to flip 4/3. Now simplify before you multiply. Both are divisible by 4. 1 times 1, 4 times 3, and you should get 1/12 as your answer. See, not bad, right? Just review. This is all review. That's why we're doing all of this kind of in one lesson. I'm sticking the 1/5 and 1/6 lessons together. Okay, so let's summarize. When you multiply, remember multiply and divide, no common denominator. So multiply, I want to remember to simplify before I multiply. Okay, I don't just multiply straight across. I got to simplify first. Then when it comes to division, remember with division, you're changing it into a multiplication problem. So to do that, you're going to want to keep, switch, flip, and then you simplify before you multiply. Okay? Thank you for joining me. Hopefully you feel like you can add, subtract, multiply, and divide rational numbers. And good luck with your practice.